Let's use some simple antiderivative formulas to calculate the following antiderivatives. So let's get started. Question A says let's calculate the indefinite integral, or the antiderivative of x to the power of 6 dx. And knowing our formulas for antiderivatives, this is equal to 1/7 x to the power of 7 plus a constant. And we can double check to see if we're right, because if we actually take the derivative of what we just calculated, the 7 comes down, cancels out with that 7, x to the power of 6, the derivative of c is 0. So the derivative of the thing on the right hand side is actually just x to the power of 6, which is precisely what's in this integration here. So we can double check to make sure that we're correct on that one. Let's move on to the next one. So we're looking for the integral of the number 9 dx. And we have an antiderivative, or an indefinite integration formula for this. This is just 9x, so the constant that's in there, 9. 9 times x plus some arbitrary constant c. Again, if we differentiate what we got on the right-hand side, we'll find out that we have exactly what's inside our integral there, which makes sure that we're right. And finally, let's do this integration. So the integral of e to the 3x dx. We again have a formula for this, which is 1/3 e to the 3x plus an arbitrary constant c. And once again, it's always a good idea to double check to make sure you're right. So if we actually took the derivative of what we have on the right hand side, what we would end up with is this, using the chain rule, we would have e to the 3x, and then the derivative up here would be 3, and so that 3 cancels out with that 3. The derivative of the constant obviously is 0, and so if you took the derivative of the right hand side, what you'd end up with is e to the 3x, which is exactly what we're trying to integrate here. So knowing that, we know that our solution is correct.